Microsoft just dropped something that completely changes the economics of building AI agents. And honestly, the whole agentic AI world is still processing what this means. We're talking about FARA 7B, a 7 billion parameter model that doesn't chat, doesn't summarize, but actually uses your computer like a real human. Mouse movements, keyboard typing, clicking on exact coordinates, the whole thing. And the crazy part is that it runs entirely on your device. No cloud dependency, no data leaving your machine, no latency spikes from round trips to Microsoft servers. This is their first computer use agent small language model, and it just beat GPT-4o on web navigation benchmarks while being small enough to fit on a laptop. Let me explain why this matters and why every developer building agentic systems should be paying attention right now. So here's the problem Microsoft solved. Most AI agents today are either cloud-dependent monsters that burn through API cost, or they are multimodal Frankenstein systems that chain together separate components for vision, planning, and execution. FARA 7B throws that entire architecture in the trash. It's a single 7 billion parameter model that does everything locally. Vision, reasoning, action prediction, all in one unified system that never sends your screenshots or browsing data anywhere. Now let's talk benchmarks, because this is where FARA 7B separates itself from every other computer use agent in its weight class. On WebVoyager, which is basically the standard benchmark for web agents, FARA 7B hit a 73.5% task success rate. That's higher than GPT-4o at 65.1% when GPT-4o is configured as a computer use agent. It also crossed EY-Tower's 1.57B, which scored 66.4%, even though both models are built on the exact same base architecture, going 2.5 VL7B. So FARA 7B isn't winning because it has better hardware or a bigger model, it's winning because Microsoft trained it better. On online Mind2Wave, FARA 7B scored 34.1%, which basically matches GPT-4o at 34.6%. On DeepSop, it hit 26.2%, and on the Web Test Bench, Microsoft's new benchmark designed specifically to test underrepresented web tasks like booking restaurant reservations, applying for jobs, and comparing prices across retailers. FARA 7B scored 38.4%. And here's the thing that really tells you this model is production ready. It completes tasks in an average of 16.5 steps, while EY-Tower's 1.57B takes about 41 steps for the same tasks. That's not just faster, that's more efficient, more predictable, and way easier to deploy in real workflows where every extra API call costs money. The cost difference is honestly wide. On WebVoyager, FARA 7B uses around 124,000 input tokens and 1,100 output tokens per task. Compare that to GPT-5 based set of Mark's agents, which burn through 13,000 output tokens per tasks. Using market token prices, FARA 7B cost about 0.025 cents per task. The GPT-5 SOM agent cost around 0.30 cents per task. That's 12 times more expensive. And if you are running thousands of automation tasks per day, that cost difference adds up fast. A company running 10,000 tasks per month would spend $250 with FARA 7B versus $3,000 with a GPT-5 agent. That's $33,000 per year in savings just from switching models. What makes FARA 7B so capable is how it was trained. And this is where Microsoft's approach gets really interesting. The biggest bottleneck for building computer use agents is data. High-quality logs of web interaction with multi-step actions are rare and insanely expensive to collect. A single computer use task can involve dozens of steps, each of which needs to be annotated. If you tried to hire human annotators to do this, you would burn through millions of dollars before even you had enough data to train a decent model. Microsoft's solution is called FaraGen, and it's basically a synthetic data engine that generates and filters web trajectories on live websites completely autonomously. FaraGen uses 3 stages pipeline. First is task proposal. The system starts from seed URLs drawn from public web corpora like ClueWeb22 and Tranco, which are categorized into domains like e-commerce, travel, entertainment, forums. Large language models then convert each URL into realistic tasks that users might actually attempt on that page. Think like booking specific movie tickets, creating a shopping list with constraints on reviews and materials, finding flights under a certain price, comparing products across multiple retailers. Every task has to be achievable without login or payable, fully specified, useful, and automatically verifiable. No ambiguous instructions, no tasks that require human judgment calls. The second stage is task solving. This is where things get wild. Microsoft built a multi-agent system on top of Magnetic 1 and Magnetic UI. They research frameworks for agent coordination. An orchestrator agent creates plans and directs a web server agent to browse the web and take actions. The orchestrator monitors progress, updates plans as needed, and can even engage a user simulator agent if the task requires user input, which allows for multi-turn completion. Each task and its corresponding sequence of observations, actions, and agent thoughts forms what they call a trajectory. And these trajectories are the raw training data that teaches fara 7b how to behave. The third stage is trajectory verification, and this is critical because synthetic data is noisy. Microsoft uses 3 specialized verifier agents. The alignment verifier checks if the trajectory of actions matches the task's intent. Did the agent actually do what it was supposed to do, or did it wander off into some random corner of the internet? The rubric verifiers defines completion criteria and scores the trajectory against them. Did the agent complete all the sub-goals, or did it skip steps and fake success? And the multimodal verifier reviews screenshots and responses to confirm visual evidence supports successful completion. These verifiers agree with human levels in 83.3% of cases, with false positive and false negative rates around 17 to 18%. That's strong enough to filter out most of the garbage while keeping the high quality trajectories. After filtering, FaraGen produced 145,603 verified trajectories with 1,010,797 steps across 70,117 unique domains. The trajectories range from 3 to 84 steps with an average of 6.9 steps. And here is the part that really shows the diversity of the data. About 0.5 unique domains per trajectory, which means many tasks involve websites that don't appear anywhere else in the dataset. The model isn't just memorizing common patterns, it's learning generalizable behaviors that transfer across completely unseen sites. And generating this data with premium models like GPT-4 and o3 cost roughly $1 per verified trajectory. That's cheap enough to keep iterating and improving the dataset without blowing through millions in computer costs. Microsoft trained fara 7b using supervised fine-tuning on approximately 1.8 million samples. That includes the FaraGen trajectories broken into observe, think, act steps, grounding and UI localization tasks, screenshot-based visual question answering and captioning, and safety and refusal datasets. And the base model is Queen 2.5 VL7b, which was chosen specifically for its long context window, up to 128,000 tokens, and its strong ability to connect text instructions to visual elements on a screen. And here is the key insight. While the data generation pipeline required a heavy multi-agent system with multiple models coordinating in real time, fara 7b itself is a single model. Microsoft distilled all that complexity down into one compact agent that doesn't need scaffolding at runtime. You just feed it a screenshot and a task, and it predicts the next action. The model operates by visually perceiving a web page and taking actions like scrolling, typing, and clicking on directly predicted coordinates. It doesn't rely on separate models to parse the screen. It doesn't use accessibility trees or DOM parsing or any of the brittle hacks that other systems depend on. It interacts with websites using the same modalities as humans, which means it sees what you see and it clicks where you would click. And because it's only 7 billion parameters, it's small enough to run on device, on a Copilot Plus PC with an NPU, on a laptop with a digital GPU, even on some high-end tablets. The entire inference stack stays local, which means your screenshots and action traces never leave your machine. Now let's talk about what this means for real deployments. Running an AI agent locally dramatically reduces latency. No round trips to the cloud means interactions are smoother and more responsive. It also enhances user privacy because sensitive data remains on the device. If you are automating workflows that involve internal company accounts, processing sensitive customer information, or handling anything covered by HIPAA or GLBA, you can't have that data flying to Microsoft servers. fara solves that problem by keeping everything local. And for enterprises, this is a massive unlock. You can build automation for tasks that were previously off-limits because of regulatory constraints. Microsoft also built in safety features specifically designed for computer use agents. The model was trained to recognize critical points, which are defined as any situation requiring a user's personal data or consent before an irreversible action occurs. Things like sending an email, completing financial transaction, entering payment information, submitting a job application. When fara 7b reaches one of these points, it pauses and explicitly requests user approval before proceeding. This is critical because agentic systems that take actions with real-world consequences need robust safeguards. You cannot have an AI accidentally buying products sending emails to your entire contact list, or submitting forms without permission. The team also trained the model to refuse harmful tasks. It incorporates critical point recognition, situations requiring user permission or sensitive information to safely hold actions, and it underwent automated red teaming to assess risks, including grounding failures, jailbreaks, harmful content generation, and copyright violations. Microsoft acknowledges that fara 7b shares limitations common to other AI models: potential hallucinations, mistakes in following complex instructions, accuracy degradation on intricate tasks, but the critical points mechanism and refusal training significantly reduce the attack surface compared to models that just execute whatever you tell them to do. Microsoft released fara 7b under an MIT license, which is explicitly designed for commercial use. It's available on Microsoft Foundry and Hugging Face, and it integrates with Magnetic UI, their research prototype for agentic interfaces. They are also releasing a quantized and silicon-optimized version of fara 7b that will be available to install and run on Copilot Plus PCs powered by Windows 11. That version is optimized for NPU execution, which means it will run faster and consume less power than a generic deployment on a GPU. And because it's open weight, any developer can fork it, fine-tune it on their own tasks, and deploy it without asking Microsoft for permission. The community response has been surprisingly focused on the practical implications. AI researchers on X immediately started talking about how this changes the economics of agentic automation. One developer pointed out that fara 7b gives you pixel sovereignty, meaning screenshots and reasoning stays on your device, which is critical for regulated sectors. Another highlighted the cost accuracy trade-off, noting that fara 7b provides better performance per dollar than any other computer use agent currently available. And several enterprise teams mentioned they are already experimenting with applying these techniques to their own internal automation workflows. Now, independent verification from BrowserBase, which is a trusted external group, showed that fara 7b achieved 62% on WebVoyager when evaluated by human annotators. That's slightly lower than Microsoft's internal benchmark of 73.5%, which is normal. Internal benchmarks often include retries when environment errors occur, while independent evaluations are stricter. But even at 62%, fara 7b is competitive with much larger systems, and it's doing it at a fraction of the cost and with full on-device execution. What really separates fara FB from other computer use engines is the combination of efficiency, privacy, and performance. You are getting a model that runs locally, costs 12 times less per task than GPT-5-based agents, completes tasks in half the steps of comparable 7b models, and still beats GPT-4o on web navigation benchmarks. That's not a trade-off. That's a straight-up win across every dimension that matters for production deployment. And Microsoft isn't stopping here. The research team explicitly said they will strive to maintain the small size of their models moving forward, which means future versions will focus on making the models smarter, not bigger. One question people are asking is whether fara 7b can handle tasks beyond web automation. The current release is optimized specifically for browser-based workflows: booking travel, filling forms, comparing products, searching for information, managing accounts. But the underlying architecture, a vision language model that predicts grounded actions from screenshots, is general enough that it could transfer to other domains. Desktop automation, mobile app navigation, multi-app workflows across different platforms. Nobody tested that yet, but the core techniques of synthetic data generation, multi-agent training, and visual grounding are modular enough that developers could adapt them to new use cases. Microsoft also introduced WebTail Beams as part of this release, which is a new evaluation benchmark focusing on 11 real-world task types that are underrepresented or missing in existing benchmarks. Things like booking movie and event tickets, restaurant reservations, comparing prices across retailers, applying for jobs, finding real estates, and complex multi-step tasks that span multiple websites. The benchmark includes 609 tasks across diverse categories, with the first 8 segments testing single skills on a single website and the remaining 3 evaluating more difficult multi-step or cross-site tasks. This fills a major gap in the evaluation landscape because most existing benchmarks focus on generic web navigation and miss the specific workflows that enterprises actually care about. The timing of this release is also interesting. Anthropic launched Cloud's computer use feature in late 2024. OpenAI released their operator agent with computer using agent in January 2025. And now Microsoft is pushing fara 7b as an open-weight on-device alternative. The entire industry is converging on computer use agents as the next major unlock for agentic AI, And Microsoft is betting that small, efficient local models will win over massive cloud-dependent systems. And based on the benchmarks and cost analysis, that bet looks pretty strong. That's where we will wrap it up. Fara 7V is one of those infrastructure releases that doesn't get as much hype as a new frontier model, but it's the kind of work that makes the next generation of agentic automation possible. Drop your thoughts below. If you build AI agents or you are working on desktop automation, I will love to hear how you are tackling these problems. Make sure you are subscribed, hit the like button, and I will see you in the next one.